Hello students, I am Dr. Krishna Kumari, Assistant Professor, Department of Mathematics, SRM Institute of Science and Technology, Kattanguluttur. This session is based on correlation statistical analysis, which is an important topic in probability and statistics. In this session, we are going to understand how two variables are related to each other and how we can measure that relationship mathematically. We will mainly focus on two methods, Carl Pearson's correlation coefficient and Spearman's rank correlation coefficient. These methods are extremely useful in many real-world applications such as data science, machine learning, economics, and educational research. For example, does more time lead to higher marks, or does advertising increasing sales? So these types of questions can be answered using correlation. So by the end of this session, you will be able to understand the concept clearly, interrupt correlation values and solve problems step by step. Now let us begin with the basics. What is correlation? Correlation is a statistical measure that tells us whether two variables are related and how strongly they are related. So let us understand this with simple examples. So what is positive correlation? If one variable increases and if also the other increases, then that is called positive correlation. For example, more study, more result. Then what is negative correlation? If one variable increases and if the other decreases, then it is called negative correlation. For example, more speed, less time travel. If there is no pattern, then that is called zero correlation. For example, shoe size and intelligence. So these are some examples of zero correlation. The correlation coefficient always lies between -1 and +1. So +1 indicates perfectly positive relationship and -1 indicates perfectly negative relationship. And if the range is exactly 0, then it is called no relationship. So correlation does not imply causation just because two variables are related, and it does not mean one caused the other. For example, ice cream sales and the drowning incidents, this is not going to be the relationship between the variables. So they may increase together, but one does not cause the other. Now let us look at the two major methods of correlation. So first is going to be Carl Pearson's method. So this method measures linear correlation and uses actual numerical data. That means it works best when data is quantitative and when the relationship is linear. So in Carl Pearson's method, it is the most commonly used method, and the formula is going to be R is equal to summation of xy divided by root of summation x square into summation y square, where x is also indicates the deviation from mean and y also indicates the deviation from mean. So x and y are going to be the variables. The three ways to compute Carl Pearson's coefficient is through direct method, actual mean method, and shortcut method. Now let us understand the key properties of this method. So here the values lie between -1 and +1, and as I said before, if R is equal to +1, then it is said to be perfectly positive, that is the correlation is perfectly positive. And if R is equal to -1, then the correlation is perfectly negative, and if R is equal to 0, then there is no correlation. So Carl Pearson's correlation is represented by R. We should also remember that it has no limits, that is no units, and it is independent of scale and origin. So when we will be using this method? So we usually make use of this method when the data is numerical and when the relationship is linear. Now let us move on to problems that is based on Carl Pearson's method. So this is going to be the first problem. Now let us solve this problem. So here it is given that the value of n is equal to 10 and the value of x is given. So summation of x, that is mean of x, is going to be 60 and the summation of y is going to be 40. And then we are going to find x square. So summation of x square is going to be 494 and summation of y square is going to be 212. And by the sum of x and y, that is xy, summation of xy is going to be 288. So now we have all the values, and if we apply the values in the given formula, we will be getting the R value as 0.575, which is approximately equal to 0.58. So from this we can interpret that the given sum is moderately positive correlation, because it is above 1 but it is less than plus 1. So the given sum is moderately positive correlation. So this method is actually an example of direct method. So now let us see another example based on Karl-Pearson method. So here we are making use of actual mean method. So according to the question, find the coefficient of correlation between x and y. And they have also given the values of x as well as the values of y. So the mean of x is going to be equal to 5 and mean y is equal to 15. Then we are going to compute summation of dx square is equal to 60 and summation of dy square is equal to 60. Then we are going to find summation of dx and dy, which is equal to 56. Now by applying all the values in the given formula, we will be getting the R value as 56 divided by 60, which is nothing but 0.93. So 0.93 is much more nearer to plus 1. So we can interpret that the given problem is very strongly positive correlation. Now we can move on to the second method, that is Spearman's rank correlation method. This method actually makes use of ranks instead of actual values. So it is suitable for qualitative or ordinal data, and it is not actually suitable for actual numerical data. For example, Spearman's rank correlation is usually used for ranking students. It is used for customer satisfaction levels, that kind of sums. An important similarity between both the method is that the result always lies between -1 and +1. So whatever method we are making use, depending upon the question, whether it is going to be Karl-Pearson's method or Spearman's rank correlation method, the value, that is the coefficient of correlation, will always lie between -1 and +1. And also this range helps us to interpret the direction as well as the strength. So now let us see in detail about Spearman's rank correlation. So the formula for Spearman's rank correlation, it is represented by rho, which is equal to 1 minus 6 summation d square divided by n into n square minus 1, where d represents the difference in ranks. So when to use this method? So this method is used when the data is ranked, when the data is qualitative, and when the distribution is non-normal. So we have to remember this. And if the ranks are equal, we usually use correction factor. And at the end, the interpretation is going to be whether it is perfectly agreement, that is +1, or whether it is going to be perfectly disagreement, that is -1. Now let us move on to a problem based on Spearman's rank correlation. So ranks of 10 students in statistics and mathematics are given. So the question is, are the two subjects related? So we are here, they have given statistics ranks as X and mathematics ranks as Y. So in the question itself, they themselves have given the rank. So our only duty is going to find the difference between the ranks, that is X minus Y. So after finding the difference, we are going to find d square, that is square of the difference, and we are going to find the summation of d square. So in this question, summation of d square is going to be equal to 36 and the value of n is going to be 10. So since here no ranks are repeated, here we are going to use the formula for non-repetitive ranks. That's what I said. Rho is going to be equal to 1 minus 6 summation d square divided by n into n square minus 1. So by using the formula and by applying the values, we will be getting 1 minus 0.219, which is equal to 0.781. So from this, we can conclude that this problem has an high positive correlation. That is, there exists an high positive correlation between the performance in statistics and mathematics. Now let us see another example, that is tied ranks. That is when two values involve tied ranks. That is when two values have same ranks. So in this question also, a set of x values and a set of y values is given. So totally 10 number of x values and 10 number of y values are given. So the value of n is going to be equal to 10. Our next step is going to, we are going to allot ranks for x, which is denoted here as R1, and we are going to allot ranks for y, which is denoted here as R2. Now, if you note that in x, the fourth value 86 and also the fifth value 86, both are going to have the same ranks 4 and 5. So we cannot 4, both are going to have same ranks 4 in the place of 4 and 5. So we cannot allot for both 4 ranks because this is going to be a tied rank. So instead we will be allotting it as 4 plus 5 divided by 2, which is going to be equal to 4.5. So in both the places we are allotting ranks as 4.5 and 4.5, and then the next rank will be 6, which is allotted to the value 77. So here it is evident. So in R1 there is repeated ranks and in R2 there is no repeated ranks. After allotting the ranks to all the 10 values, we are going to find D. D is nothing but R1 minus R2, and then we are going to find D square. So in this question, the value of D square is going to be summation of D square equal to 44.5. Now, since this question involves tied rank, the formula here we are going to apply is going to be rho is 1 minus 6 into summation of d square plus summation of m into m square minus 1 divided by 12, the whole divided by n into n square minus 1. Here m represents the correction, that is how many times, how many values have been repeated. Here only one value, that is 86, has been repeated twice. So in the place of m, we will be writing it as 2. So summation of 2 into 2 square minus 1 divided by 12, which is equal to 0.5. And for summation of d square, we are applying the value as 444.5. So by applying all the values, we will be getting the value of rho as 0.727. So from the question and from the answer, it is very evident that the given values x and y are strongly positive correlated. So now let us compare both the methods. So from the table, it is evident that Karl Pearson method uses actual values and it measures linear relation, while Spearman uses ranks and it works with ordinal data. So we should mainly remember that for numerical data, we will be making use of Pearson method, and for ranked data, we will be making use of Spearman method. And this Karl Pearson method is for Karl Pearson method as well as for Spearman method, the range, that is the correlation range, will always lie between -1 to +1. And also, since Karl Pearson's method does not involve any ranks, tied ranks is not applicable for Karl Pearson's method, but for Spearman method is involving only ranks. Therefore, tied ranks is applicable for Spearman method, and in order to correct the tied ranks, we will be making use of the correction factor values. Let me conclude this presentation by summarizing the key concepts we have discussed regarding correlation, specifically focusing on Karl Pearson's and Spearman's method. So correlation is a statistical technique that helps us understand the relationship between two variables. It tells us whether the variables move together, and if they do, whether the relationship is positive, negative, or absent. We first discussed Karl Pearson's coefficient of correlation, which is one of the most widely used measures. It measures the linear relationship between two continuous variables, and the value ranges between -1 and +1. So +1 indicates perfectly positive correlation, -1 indicates perfectly negative correlation, and 0 indicates no correlation. We should remember that this method is best suited when the data is numerical and continuous, and when the relationship is linear. There are no extreme outliers affecting the data. However, one limitation is that it is sensitive to outliers, meaning a few extreme values can significantly affect the result. Next, we explored Spearman's rank correlation, which is a non-parametric method. So instead of actual values, it uses ranks of data. So it is useful when data is ordinal, when the relationship is not strictly linear, and when the data set contains outliers. So Spearman's method is particularly helpful in real-world situations where exact numerical values are not reliable, or when we are dealing with rankings or preferences or qualitative comparisons. So an important takeaway from this presentation is knowing when to use which method. So use correlation method when the data is precise and numerical and when linear relationship is expected. And we have to use Spearman's rank when data is ranked or ordinal and when the relationship may be monotonic but not linear, and also when the outliers are present. So this distinction is crucial in research and data analysis, specifically in fields like machine learning, economics, psychology, and social sciences. And also, we should remember that correlation analysis plays a vital role in predictive modeling, feature selection in machine learning, identifying trends in data, and decision making problems. So, to conclude, both Carl Pearson's and Spearman's correlation methods are powerful tool to analyze relationships in data. The key is selecting the appropriate method based on the nature of the data and the research objective. I hope this session has helped you clearly understand the concepts, difference, and applications of these correlation techniques. Thank you.